Okay, so local ecosystems. This unit is a warm up. It's a warm up into some pretty complicated systems we're going to talk about past this first module. Okay, so sometimes people can be like, oh, but like this is like middle school stuff. And I want to remind you that middle school's been a long time. Okay, so some of these definitions may challenge you, may not remember it, but this is going to be important, a key part of your observations right now. Okay, we're going to start learning how the scientific view of nature can actually help shape ways that we see a landscape and then be able to utilize those observations into a functional design. So this first layer is now beginning to understand how those ecosystems work. Each of you have been, excuse me, I'm trying to move this around to where, okay, there we go. Each of you have been doing observations for the past several weeks on your sites as part of the assignments for our first module. And so the assignments that we're trying to work towards right now is choosing our design site that we're going to be doing and presenting our design for, and sitting with the land. That one of the first classes we did that mindfulness activity, that meditation, where I guided you through a practice of really leaving the running mill of thoughts in our mind, right? That endlessness that can be really, really loud, and stepping more into our body, into the feelings of our body, and then kind of grounding out our energy. So when we're observing and we're looking into nature and we're looking at these design sites, it's really difficult for us to get clarity and actually real observations if we're not having a mind that isn't overthinking on top of what we're seeing. So a huge key part of actually being able to apply knowledge and wisdom into a design site is having this clear, open observation. So what does an observation actually look like? Right? Because people can say that all the time, like, go observe, go do these things, right? But what does it like tangibly actually look like? Somebody give me an example. Nala.
I mean, an example of observing, I feel like my logical mind wants to go and like look specifically at things, be like, what kind of tree is this? And that's all fine and dandy, but I think a really important part of observing is not searching and having no expectations and just sitting and letting your senses remain open. I think it's the combination of being logical and being intuitive.
Mm-hmm. And Jasper, what is an example of an observation?
So like I tend to stick with like senses as well as feelings. And also like changes that I've noticed. So like seeing like I saw a flock of sparrows today. They were in the low brush, like they were flying over the fallow fields, or like I saw a murder of crows or an attempted murder of crows, where there's only two of them. So like but also like it was cloudy today, or we had a chance of rain and it didn't. Those were the kinds of things that I ended up writing down. And then over time, I have things like starred, where it's like an observation that I've noticed over time or how it's changed over time. So, but usually I stick with like senses, like sight, smell, sound, touch, and then also a bunch of statistics. I'm keeping an almanac in here.
Yeah, I mean, that's kind of what like an almanac is, right? So people who over time took these observations and cataloged it and observed patterns. These are real observed patterns for their bioregion. So then they were able to look at this data, these observable data that they collected over time, and then be able to chart patterns. That was what an almanac was. It was someone who went to each of the farmers and was like, hey, what are your observations for this past year? And then they went back and they looked at all these different observations and they charted patterns and they correlated it to past years, what it meant for the following year. Does that make sense? This really importance of observations is actually going to allow us to predict what is coming. And I know that sounds absolutely insane, and maybe like some people are like in this climate, and it's true actually, because there are patterns to the climate, what is currently our climate crisis. There are patterns, and there are things that we can chart in very short spurts. I wouldn't say that we can say like we can chart a whole like 5 years, right? Because of how chaotic it is, but we can chart small sections, maybe even a season, maybe even like a couple seasons. Hopefully we can get to a year as we get more of an ecosystem established on this planet. More of us are doing that. So what are some key things to remember while we're observing, Laura?
It's important to keep the big picture in mind when analyzing your observation, but also to be present when observing and take in all the information that you can.
Yes, thank you. And Andy, what may I record afterwards? Like, how may I structure that? What are some key things that I want to make sure I record every time after doing a sit session?
Date and time,
Yes. What else?
weather,
Yes.
um, every time I'm struggling with anything else. Like I just feel like when I have documented my garden, I'm documenting temperature, you know, and like just really tracking things that, like you said, I can quantify and use to predict, you know, to help me understand, okay, when next year that I need to do something like, you know, to extend the season, or and I don't know if I've missed anything, but those are the things that come to mind.
Absolutely. Some other things you might want to consider is having a rain gauge and recording how much rain, just recording what it is, what level it's at the rain gauge. Because that can do two things. One, it can show you how much it rained, but also if a rain gauge is evaporating really quickly, that can also show you that maybe you're having really high temperatures, maybe it's really, really dry, it might be really windy. Something else that I recommend that you do on your design site is get a stick as tall as you can that would be stable and put a piece of fabric on it and just see what direction the wind is blowing and just record that as well. You're doing your observation, put that near your sit spot or one of your sit spots and just record the direction that your wind is blowing. Something else to consider is recording is your feelings. How did you feel and your interaction with the land go that day? Because actually, you know, the land is going to respond to you, right? And like you also having that relationship with the land and charting that over time, you're going to be able to identify, you are going to feel different with the land expressing itself in different ways. You're going to have a reaction to that. And that is called intuition. And it's going to be difficult at first to know what your intuition is telling you about the land from ancestral knowledge if you don't chart it. So you need to start to write down how you're feeling before you enter the site, while you're on site, and when you leave, because your ancestral knowledge is reacting to what you're seeing and experiencing on the land. And over time, you can lean into those feelings and know, oh, a rainstorm is coming tomorrow, because you've been able to track the data and correlate it to intuitive feeling, and then you know that it's true. It's hard for us these days because we don't have elders who teach these things to us when we're little tiny children. So we have to use what we were taught in our educational systems, which is the scientific method and observing, to then correlate it back to this ancestral knowledge we do know. Jasper, you had a question?
I was gonna more of a comment, but like something that I noticed while doing my observations is that I've been able to really track my like good days and bad days for my chronic illness by looking at the precipitation, which direction the wind is, like the wind current, and the barometric pressure. I think that'll be, or no, But
Mhm. Like if a storm's
yeah.
coming in or
Yeah, or if
leaving
there's
and like pulling
there's
it out.
if there's two fronts battling each other,
Mhm.
and that's passing through my area, I'm gonna feel like crap. And then on days like nice clear days, or even on days where it's like consistently rainy, I'll feel tired or things like that. So I like track my own like, just by taking these observations. It's been really cool.
Yeah, absolutely. And then the last layer I kind of want to add to this is as you begin to see these like hard data points, you yourself are recording and correlating data with your own self, your own intuition. I also want you to begin to recognize the other relationships on their land and how they're acting. You know, because if a rainstorm is coming, you will see fire ants build a massive pile on top of their entrances because they're preparing for a massive rainstorm. If they know that a rainstorm is coming where the conditions are for it to flood, you'll actually see them moving their eggs to a higher ground, whether that's in like leaves or like up on a tree. So even just these micro things, like how are the groundhogs different today? What about the murder of crows? You know, like where are they consistently sitting? And seeing how that is also relating to these other data points. So now you're integrating yourself into an ecosystem, right? So you figured out these data points of things that we know and have been ingrained in us in our current society. All right, let's lean into that and let's utilize that as a tool, as leverage to learn about this intuitiveness and then integrate ourselves into an ecosystem. Is this making sense?
I have a question, if you don't
Mhm.
mind.
Yeah.
If I can only be up there once a week, which is pretty much average to what I've been doing. And when I'm there, I'm typically building. So I'm not, in the beginning I was able to go and just sit, but right now when we're up there, we're building. And I haven't been great about just taking a moment. So I go back and I've been documenting some of my feelings and reactions and like journaling some of the things that I remember from being up there. But I realize that's totally not the same. But do you feel like that's enough? Do you feel like that's, that once a week sort of, if I take, 15 minutes to just go sit in the same spot, like it hasn't been the same spot. So I like that I picked up from this is that it needs to be kind of maybe the same spot. And obviously I think that would be our home site. So,
I definitely think it's going to be okay. And
okay.
it's enough. I would challenge you to increase the amount of time. So I know you're feeling like a lot of anxiety around and like pressure to get your deck up, but also know the importance of these observations as you're moving forward. And that having this data for you, and then also as you're building out your eco village, having this data that's really clear and taking that time to do it, how impactful that's going to be for you later on. And that you're going to actually be really grateful, I feel like, to have that information also. And also as you're bringing in and interacting with other people on that land, I think having that information is going to be really impactful for them too. You may feel better if instead of like sitting in a spot for 30 minutes plus, right? Maybe doing a walk. I used to do, especially because you have so much land. I used to do when I was a steward of 70 acres and I was designing on site for my homestead and others. I would just walk the land and then I would end it with at my sit spot and then I would journal.
Okay.
Because it was like moving my body, but I also. So we're going to start getting into the basics of ecology. We're going to go over some definitions. We're going to start talking about what are the different parts of an ecosystem. What does it mean to live in an ecosystem? So first, I want all of us to look at this this diagram, this picture right here. And so our current state of reality of most people exist just in this realm right here. Right? So most people exist in just this I, the individual. and this one circle. And our society today mostly exists within these two right here, the individual and then the population directly around that individual. Now, with technology these days, we have been able to go out further in our community and be able to connect. But in reality, when you look at someone who works in the typical societal structure, a 9 to 5, has a family, maybe some commute time, this is about their reach, is an individual and then a population. And the focus still, I would say 83 to 90% of the time is on the individual, maybe even just the nuclear unit of a family. You could replace that with the individual as well. And so when we're in an ecosystem, when a singular species is in an ecosystem, it is aware of its entire ecosystem and its impact on it. It isn't living within an individual or a population. What does it mean when it says population versus an individual, Carol?
It means, so let's say individual and you've got your little slice of pie, right? Your house, your nucleus there with your family, whether it's you and kids or not. And then the population, I would think, would be your immediate like area that you live in. Not even that broad, because then you're going into community, but population maybe being your neighborhood,
Yeah.
and your local places that you visit and frequent or buy from or whatever.
Exactly. And then Jasper, what does it mean, like if we're zooming from population out to community, what does that mean?
I would consider that to be like going from your neighborhood out to your town or your like city, or maybe not even your city, but like if you're in like a metro area, just like the borough, of like, it doesn't even have to be like the whole city because metro areas get massive, but like I might even consider just the neighborhood to be like still to be also part of community, but community is just like, it's like the people you interact with at the store that you frequent, or like the people that you see regularly at restaurants if you still go to those, like things like that.
I would definitely say that a population would be a neighborhood, and then the community might be the collective of neighborhoods in like suburbia versus like downtown or maybe west side or east side. And sometimes those have names, like in New York City, there's a whole bunch of different names for the different communities, right? Yeah, sorry, I had like a tangent. I had to shove that back in real quick. Y'all know what I'm saying. And then Andy, I'd love to hear your thoughts on the expansion from community to ecosystem.
My thoughts on that would be that, the how the community affects the ecosystem, that we sort of plop ourselves within an ecosystem without any care in the world to how we're affecting that ecosystem. And that's obviously the waterways and the animal pathways and all of the flora and fauna and the natural wildlife that live within and around us. And a lot of it happens without us even knowing, and we're not observant of that. Or even we take offense to that, like how people feel about raccoons and deer and all of that, instead of like actually trying to integrate with them. So those are my thoughts on that. But the ecosystem, I feel like, is what's outside that community, what's our natural world, and how does it all integrate?
And if we're using the example that we were saying, going from the individual household to our neighborhood to the collective of neighborhoods, maybe like a suburbia, the ecosystem might be the entire city. It might be that entire town. If we're saying rural, it would be the town and all of the surrounding farms, right? Because rural isn't just the town. The collective of people is spread out through a much wider expanse of land. So if we're talking about ecosystem for a rural town, it is also all of the farms that surround that area and feed into and take service from that town. Okay, so then when we move to a biome, Nala, what is, if we're using the same example of moving from ecosystem of that city or that town, right? What is biome in that example?
Would it be more so like country, or I guess even smaller of kind of more so where the climate and is more similar? But I mean, I guess could look at it as country, but that might be going too big. Or maybe, yeah, so like maybe smaller in terms of the words are slipping me, but in terms of like where the environment is similar.
Yes, yes, yes. And we a lot of times call that a bioregion, right? Like we look at watershed, we look at similar types of climates, and they're grouped together. So like I don't refer to countries or any sort of like state lines. Those aren't real in this example at all. Okay. That what we're talking about here are relationships and similarities of characteristics. Okay. And that's how nature has these things lined up. They don't just plop a square on top of a 2D map and say, this is this biome, North America. It is all aligned to with what waterway flows into what other waterway and where does it end up. And then the major climate similarities. And so if we're moving from a rural town, it would be a collective of rural towns and maybe a few cities that are along the same watershed, maybe the same major river that flows into the ocean. And so then that would be the biome. They have typical similar types of plants. So if you think of like the Southeast has typical native plants that are found all from like Western Virginia, not West Virginia, but Western Virginia, all the way down to North Florida. There is similar flora and plants. You can find similar soil types. There are similar dry and wet regions. So if there's a region in the bioregion that gets a lot of rain, you'll find similar plants and the same amount of rainfall typically. Now, this is changing dramatically because of climate chaos. So what we're seeing is that there's a reordering happening in our biome because of the stripping of forest, because of carbon emissions, because of industrialization, microplastics, extinction events. And so what is happening is that what used to be these similar characteristics, we're having huge, massive wipeout events of major characteristics in this biome. And so the biome is shifting dramatically and having to adapt to these things. And so it's a little harder for us these days to really have a handle on what our biomes are. And then Laura, when we move from biome to biosphere using the same example, what are we referring to?
The biosphere is everything. It's all regions interconnected, the atmosphere, and immediately adjacent to atmosphere, because that affects us too.
Exactly. So this also includes the orbital power of planet Earth. So it's not just like the land and the water and the atmosphere, but also its gravitational pull around the planet, is because that is directly affecting how that our planet exists within our universe. And so because of that, and like the way that even the individual all the way to the biosphere is affecting, that will affect the whole biosphere. Is that making sense? Something that's coming up for me is like, remember when Elon Musk Starlink, remember? And then we saw just some dramatic effects, like when we're still seeing that. Are people making those connections? Yeah. So like we can see those effects in our world right now. All right, so now let's bring this down. Like we use an example for our human species, right? And our human species is well known and it's documented that we have made an intention in our species to separate ourselves from the ecosystem. Like there was a decision that it was easier to control and manipulate instead of trying to be in a co-creation, a reciprocal relationship in an ecosystem, because that's a requirement in an ecosystem, right? And let alone a biome. When you have multiple ecosystems in a biome, man, think of all the reciprocal and co-creative relationships that have to occur, right? That's a lot. It's a massive amount. And so we as humans have decided that we're going to try to control where we think our limit is. And our limit, we think, is in our community, right? Or in our cities. I laugh and I chuckle because it's not really that true. But then we think about nature and we think, like looking at this example here, where there's a singular moose and then it's the moose's family, and that moose is traveling all throughout its entire biome, right? It's a migratory animal. And so even that individual is directly relational to the biome at all times, because as that biome is changing through the seasons and resources are becoming depleted or abundant through that sine wave of nature expression, right? We're going to see that individual changing its patterns within a population, a community, and an ecosystem to fit the characteristics of its biome. And that in itself is a natural expression of an individual. Is that making sense? So these are the practices and the characteristics and the mindfulness and the relationships that we're trying to come back to. Are there any questions about what I just said? Cool. Okay, so now let's get down to some more intense, like we just looked at a really wide view. Now let's step in a little bit closer and take a look. And what we're looking at is something called a community ecology. By looking at this diagram, who can tell me what does it mean when it says community ecology? Casper?
So that would be like the entire food web and like everything that relies on each other for like at every life stage. Like the heron relies on the like frogs, relies on the like dragonfly nymphs. Like dragonfly nymphs are metal, like they destroy fish eggs and stuff like that. And so like, and then the plants as well that they eat or that other animals eat. And so like it's just the entire food web, and like even down to the like microbes in the soil that help keep the trees healthy. And
What are these right here?
yeah, well, but that looks like a beetle.
Yeah.
It looks like one of them beetles that burrows into the tree bark and kills them.
And
Now-
why is there no arrows between, you see how you were just describing these relationships, and these arrows are those relationships, right? So
Mhm.
why aren't there any arrows between these down here and this food web up here?
That's a good question, because I figure that at the very least, some types of birds will eat worms if they can get them out of the soil, and then the beetles also tend to like burrow into trees. So it just depends on if they have like things that eat them or not.
Carol, you had something to add to that?
Yeah, excuse me. I would think that they are decomposers as well as, so they help with that cycle of closure, really, end of life.
Exactly. Exactly. This is the representation of the decomposers in this entire ecology, community ecology. So these look like feeding relationships, right? And sometimes there are feeding relationships between these organisms and down here, but this is just a base representation of those decomposers. So what would you define community ecology as? Andy. Sorry, Carol, I just missed your hand.
Well, it's the web of interaction with all of these the species and how they serve each other, and it's the system. It's not an ecosystem, but it's a system within the ecosystem, I guess. Like how, like I mean, all these arrows are just fun to me. Like, yeah, it's a food chain, but also, a resource chain.
Carol, did you have something else you would like to add?
Andy said it well, the food chain. I was thinking, gonna say the hierarchy of the food chain and how things, I wouldn't say it's a symbiotic relationship, but community in a way would create a relationship that is all supportive.
And what would happen, Nala, if say I took out the snake right here? Like we had a mass extinction event, right? And the snakes just disappeared. How would this community respond to that?
Yeah, you could see an increase of, the food that the snake eats or a decrease in what eats the snake. And that could affect the whole chain or web.
Is it going to completely wipe out this whole food web?
I'd say no. I'd say it would just create an imbalance.
And Laura, how would this food web respond to that imbalance?
The other creatures would either adapt or they would die out
Exactly.
that are related to it.
And then how does their death serve in the purpose too?
The decomposers are processing them and making the raw materials for plant life.
Exactly. And so even through the death of losing maybe another part of this food web, that energy is still in this food web. It's not just disappearing and being moved completely to somewhere else. Is that making sense? Are there any questions about community ecology? Cool. So there are, sorry, I'm doing the moving thing. I laugh at myself. There are two different factors in a ecosystem. It's called biotic and abiotic. And this is a really great diagram of showing you kind of biotic versus abiotic. So when we break down the word, bio means what? Popcorn.
Life.
Life. And then what does mean if we break down, separate the out?
Not.
Without, exactly. And so when we say biotic, we say life versus without life. And those, when we look at an ecosystem or we look at an environment, just really straightforward, right? Like we remove this emotional thinking part of our body. Some may call it our soul, so we're just using the muscles of our brain, and we're just looking at our environment, and we're looking at the life part versus the without the life part. We can see these two things and gain a lot of knowledge. So give me some examples of the things that are life.
Animals.
Plants.
Yeah. What else is on here?
I would argue viruses and bacteria.
That's what this little guy is.
Yeah.
I was going to say single-celled organisms.
Yeah, like algae in oceans are huge. Plankton.
Humans.
Humans. Can we name anything else that's alive in our ecosystem? Oh, Carol?
Anything that needs to consume some sort of food in order to maintain life.
Exactly.
Fungi.
Yeah. And so these are things that we can visibly see in chart. And then when we talk about things without life, right? What are these? Give me some examples of what these things are.
Rocks,
Wind.
minerals.
Rock, wind, minerals,
Rain,
water,
smoke,
maybe particulates.
mm,
What else is on here? What is this right here?
humidity.
Temperature.
Temperature, humidity, humidity. What is the other thing that we chart in climate?
Air pressure.
Air pressure. And what do these all have in common?
They're elements.
They're elements. And do they require energy in order to live, to exist?
Yes.
In what forms?
Kinetic,
Yeah, versus
pressure,
what of the life part? The biotic part. What's that difference?
the food versus force.
This is a tricky question. It's a trick question, by the way, because they both require kinetic energy in different ways. Does that make sense? So biotic life a lot of times need kinetic energy in the form of bonds, right? And abiotic uses kinetic energy a lot of times through elemental ways like pressure or heat. It is, it's similar in ways, but does that make sense? I'm trying to really simplify a really complicated topic, but I think you're all understanding what I'm getting at.
Would you say that like biotic is the type of life that needs to eat, and then abiotic is like more like physics based?
Well, if you think about it, like biotic, it requires an input of some kind, whether it's like for cell division, like some sort of energy from an outside source, or procreation or to grow, right? Like consuming energy in order to then break it down. Versus a lot of times the abiotic has the energy like applied to it. So if you think of like how rocks are made, it's like the pressure, the energy is applied to that. Or if you think about like temperature rising, it's the collection of heat in a specific area. Okay, so what we were discussing was ecosystems, right? We just learned about abiotic and biotic factors. Now let's talk about what is an ecosystem. Laura, we haven't heard from you in a minute. I was waiting for people to settle.
Sorry.
You're good.
I was like, oh, where's my cursor? An ecosystem is the interrelationships of biotic and abiotic. So it's how everything relates to each other and everything affects each other.
And how far is that reach, Nala? Remember we talked about going all the way out to the biosphere, right? And from an individual, where does that sit in those rings?
Can you, my brain is just coming back from running around. Can you word that one more time, that question? Oh, you were asking like in between what?
Mm-hmm.
Oh, okay. So
bringing back the reminder to hear.
yes, yes, ecosystem in between community and biome. So not quite like the small group and not as much as the vast biome, but a bit in between.
Did we lose Jasper? No, there you are. I just lost you on my screen. Sorry. I was trying to find you there for a minute. Okay, I'm sorry. If it's a little scattered right now, coming back from break. Any questions about ecosystems? I feel like this is something that's we all know really well because we're taught. This is very heavily taught. So any questions about ecosystem and how it plays into the wider biome and even out to the biosphere? Jasper.
It's not a question, but it's an offering for a learning tool if anyone is interested. There is a card game called Ecologies. It's by Montrose Biology. You can get the deck on Etsy, and it goes through like food webs from like, I don't know if it goes all the way down to a microbial level, but it goes down to like the little small like plants and fungi, and then all the way up the food chain into like apex predators and things like that. And you have to like balance the ecosystem like free cell. It's a lot of
Oh,
fun.
that's cool.
It's a great learning tool, and it's got 2 expansions now to the main, including the main deck. So there's like 3 different ones that you can play. It's a lot of fun, and it's really, really great for learning the interrelationships in ecosystems. So I highly recommend. It's called Ecologies.
Awesome. Thank you. Okay, so let's talk about niche. Excuse me, I had kombucha. Just saying hello. So without just regurgitating this wonderful definition in front of your eyes, can someone re-paraphrase, Andy, I'm going to choose you. What is niche?
You want me to paraphrase?
Mhm. You can also pass.
No, I don't like to pass. Let me just work this in my head. So,
You want to call on a friend?
Dial, what is that game? Well, I feel like the niche is like each little segment of this ecosystem, right? So like what's, where someone builds their home, or I mean, I'm looking at all these birds nesting on this tree, and they're all seemingly different kinds of birds. So they all have their little niche in that tree. And it's making me think of our community and like where my little niche is going to be, which is awesomely close to Carol's. So yeah, but it's also, I read this role piece, and birds are the seed spreaders, and and thinking of that other image that you have, you've got your worms that are the digesters, and so that's what I think of as niche.
Exactly. Carol?
To add to what Andy says, each individual plays a part in the whole, creating that balance of the whole system of the community and greater.
Exactly. And something else that's really key about niche is that the position or role is placed in the community according to the needs of that position or role and the needs within that ecosystem, right? It's not just the needs of that individual or just the needs of the ecosystem. It is where both of them meet into a place of balance, which I think also what Carol was getting at. So when we look at this diagram, right, of these 3 different kinds of birds, and each of them have a specific niche in this tree, right? Because of their characteristics, maybe it's their flight patterns, maybe it's the way that they make their nest, maybe it's the food that they eat. And when you look at the tree has different characteristics as well. And those characteristics of the tree meet the needs of those birds so that they can reproduce and have harmony. Also, over time, these birds and their characteristics and their needs are going to continue to shape this tree to meet their needs. And also the wider environment of how that tree is responding in the wider ecosystem and also in the wider biosphere is going to change the way that the birds are interacting within that niche and may even change the way they meet their needs. So there is an ebb and flow within this niche. Is this making sense? So when we think of niche, sometimes we think it's like, it's a really clear-cut thing, but it's not a clear-cut thing because it's an evolving, ever in flow process between that niche being able to be in harmony within the environment that it's in. Are there any questions or anything that anybody would like to add? Cool. So now we're going to talk about ecotone. And the reason why I love talking about this, the ecotone, is because when we go back to those 12 principles, right, and we talk about marginal places, right, we talk about one of the first 5 principles is talking about utilizing the marginal. And many people would say that an ecotone is a marginal. So again, I'm just going to go ahead in reference to this diagram to explain what an ecotone is. We're looking at 2 different ecosystems right here. Okay, we're looking at an aquatic ecosystem and we're looking at a land ecosystem. And the ecotone is that transitional space between both the aquatic and the land. And the reason why an ecotone is so immensely impactful is because it has characteristics of both the aquatic and the land. It isn't fully land and it isn't fully aquatic, and it has some where they both meet. And why that is so amazing is because of the niche of animals and organisms that then thrive in those places, that need both aquatic and land ecosystems, right? They can't fully live in aquatic and they can't fully live on the land. If you think of frogs or turtles, some kinds of fish need just that shelf on the edge of an ecotone, right? And so this ecotone specifically is called a marshland. And so that energetics, you have the land organisms present in this area, you have the aquatic organisms present in this area, and then you also have that special niche of organisms that can only live in that ecotone. It's a huge amount of energy. It is a huge amount of energy exchange in the process as well. Are there any questions about ecotones? Anything anybody would like to add? And maybe any knowledge share? Jasper?
One of the major things that I've seen regarding restoration projects in permaculture focuses specifically on ecotones. Like there's a huge, like not campaign, but a huge project going on right now to plant like just a bajillion mangroves where on the coastlines where they had been previously cleared for like beaches and stuff, like sandy beaches, because all of those beaches are eroding and the fish are dying out because they don't have the mangrove roots to nest in, and the mangrove roots are not holding the land together. And so now they're doing like, they're focusing on like planting a bunch of mangroves and restoring that ecosystem.
Jasper, why are they specifically focusing on that ecotone instead of focusing maybe on the cliffs behind it or, you know, the water directly in front of it? Why are they specifically focusing on restoring that first?
Because they want to prevent the erosion before it happens. So they don't want everything to erode all the way up to the rocks. Like that's still dangerous and it still destroys a whole bunch of different ecosystems. And it like, but so they're trying to like to prevent that erosion before it happens, and then also like help bring the like land ecosystem like not closer to the shore, but they're trying to like be like, okay, well here's your boundary and here's this necessary like between ecosystem, and then you have the the ocean ecosystem and things like that. Also because water salination is a massive problem lately. So they're wanting the like desalination properties of mangroves so that they don't like have salt water just messing up all of their groundwater, because there's nothing to keep it from doing that if it's allowed to just have like land and then suddenly water.
So what Jasper is describing is that by protecting the ecotone, they're actually protecting all three ecosystems. They're not just protecting land or just protecting the aquatic, they're protecting both the land, the aquatic, and that marshland ecosystem. So that simple act of going into the marginal land between two ecosystems and rehabilitating it and reestablishing it is actually protecting all ecosystems. Andy?
Can you provide another example of an ecotone besides, the edge between land and aquatic?
So think of the land between a forest and a meadow. If we think of it isn't just forest and meadow, right? It's forest to meadow. And so it tears down and then it goes into meadow. And so that is full of a lot of fruits. It's full of a lot of brambles. It's amazing bird habitat, songbird habitat. You don't see many songbirds deep into the forest, but you'll see them very, very heavy on this thicket that lines and covers the edge of a forest, right? And so that transitional ecosystem between meadow, which is very wide open expanse, has some short trees and shrubs dotting the landscape, and then a thick forest. It's an accumulator of the really rich denseness of nutrition in a forest to a lower density of nutrition in a meadow as well. It's a place in between, and which is why actually a lot, like I mentioned it in one of the classes that you were a part of, Andy, why we see a lot of invasives coming into these types of ecosystems, because their focus is in repairing these ecotones to then help the ecosystems around them.
Thank you.
Yeah, I hope you got what you needed. Any more questions or comments, information shares about an ecotone? Okay, so then we're going to go into habitat. So that is the locality in which a plant or animal naturally grows. What is, Laura, I'm going to ask you this question. David, I'm not leaving you out. I'm not forgetting you. I'm going to include you in some questions when we get a little deeper in. I just didn't want to throw you into the pool. So I'm letting you wait a little bit before I throw a question at you. But
Well-
Laura, yeah?
Well, I was just listening to what all of you were saying, kind of like getting in tone of what is going on,
Mm-hmm.
because I was kind of lost. Sorry I came in late. Got a little busy.
It's
No.
all right.
Got
Well,
a
thank you for
surprise-
coming. Yeah.
Got a surprise visit from Puerto Rico.
Oh, that sounds wonderful.
Yeah.
So, Laura, my question for you, that one of the best questions to ask about this is, what is the difference between a habitat and a niche? Right? I see a lot of people going, Let's give Laura a chance. It looks like if you need to call a friend, Jasper can be that friend.
Jasper, will you be my friend? I'm calling on you.
Anytime. So a niche or a niche is more what you do and what you're good at, and the purpose that you serve in that environment. And the habitat is where you live.
Right. So, like, give us an example of that. David, is that to answer the questions of the raise a hand, or that you had a question? You have a question?
No, to answer.
Oh, to answer? Well, go ahead, because maybe it will answer the question I was about to ask.
A habitat is the collective area where different species could live harmoniously and together. And then the niche will be the separate area, or I would say, yeah, the separate areas where they uh, congregate by species. For example, in African savanna, you will see the lions. They will, you know, collect, or they will stay in this area and hunt through the savanna. But the whole savanna is the whole habitat for all the animals.
Absolutely. Yeah, I have nothing more to add. That was exactly the next point I was going to make. Thank you, David. Any more knowledge share or clarifying questions that people have about habitat? Okay. So biome, we kind of talked about that, right? Then the major types of habitats, the different types of climates, that similarities, right, where organisms are found. And so if you look at this map, right, sorry, I'm just shifting our faces around so that this recording, you can actually see it. If you look at this map, it actually has mapped that for us, right? We can look at the tropical rainforest. We can look at the tundra, the taiga, I never say that right, the montane, the savanna, the desert. And so these similar characteristics in climates and habitats are mapped right here. And what do these normally look like for us and us as gardeners?
Growing zones.
Growing zones, ding, 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 exactly. And so we've utilized this a lot as growers already. And the deeper you get into, even if it's just a small garden to a farming and natural habitat restoration, you get more into what plants can actually exist within these major biomes. Any questions about biome? Okay. All right, so I'm just laughing at myself because I have to move this our faces around a lot so that the recording can show. So biomass, right? It's total plant and animal matter per unit area by weight. Science, okay? So we're getting into like this math stuff. Blah. Some people, you know, their brain kind of goes gushy. Some of us get really excited about it in all sorts of ways. And so when we're talking about biomass and we're looking at this pyramid, right? So the right-hand side, maybe is it also your right-hand side where you see numbers and weights? Okay, so on your right-hand side, you can see actual weight, right? And then the pyramid is showing that area. Okay, and so when we're looking at the bottom rung, the producers, they have a significant amount of weight and they have a significant amount of area in which producers cover, right? And then the further up that we get in this terrestrial ecosystem, which is a specific ecosystem, we're seeing the weight decrease and that area also decrease. And so we're going from producers to herbivores to a primary carnivore to that top carnivore. And as we move up this food chain, right, we're seeing less weight per unit area. And that is significant, okay, because we're seeing energy decrease, right? And that's important when we're looking at an ecosystem. I'm going to move through these next ones kind of fast because one, they're just a revisitation of the definition and it'll all make sense in a later date, okay? Biogeography. So that's a study of the species and ecosystem in geographical space, but also through geological time. So this map that you're looking at right now is not the map of the world right now, right? It's the map of prehistoric time, before the continents shifted and moved to where they currently are today. Okay, so when we're looking at biogeography, we're not just looking at where is Africa right now. We're also looking at how Africa shifted over time for those characteristics to occur. okay? Because that is actually what affected the abiotic factors of our continents, is actually this geological time aspect. And it's really often ignored and not talked about when we talk about these things that we said before, such as biomes were really dramatically shaped. If we look at this biome map and how things are put together, and then we come back to this map, we could probably align a lot of these biomes that seem really dispersed in our planet right now with this conglomerate of where in this geological time that this biogeography is being expressed. Is this making sense? What I'm trying to impart on you right now is the importance of recognizing time in your observations, okay? And the importance of getting the history of something, not only abiotic and biotic and ecosystems, but also socially. So when we understand this history of over time, we can understand how these characteristics have maybe divided and spread out across biomes, niches of people, ecosystems of land over time. It allows us to understand deeper and to know how to react moving into the future. So let's just do a real quick, I'm just moving your faces around. We're going to do real quick functions of ecosystems. I'm not going to throw a textbook at you, okay? I'm trying to get your brains moving and gooey a little bit out of some rigid ways that we were taught, but also using those rigid ways to bridge a new way of thinking about it, okay? So functions of ecosystems. Number one, cleaning water through oxygenation, wind, plants, and soil. Nala, I want you to read the next one.
Prune plants with animal agents, winds, insects.
Andy, I want you to read the next one.
Fertilize soils and sow plants through composts, animal manures, nitrogen fixers, filter dust, viruses, diseases, toxins through soil, plants, aerial systems, and ground.
And Carol, the next.
Sterilize with the sun.
And Jasper.
Seed dispersal with wind, water, animals, and gravity.
Laura.
Pollinate through wind, animals, insects, water, fermentation.
Sorry, just moving your faces around. David, did you have your hand up because you still had something to say, or was that from the last time? Just checking in. You might have to click on that emoji again to lower your hand. Awesome. Thanks, David. Okay. I chuckle again because we're going back to middle school. I was emo, whoa. And so, I'm just bringing it back to my depressed age. And I remember learning about the carbon circle or cycle, and I was like, who's ever going to have to know and understand this? And let me tell you something, it's been something that's been hugely impactful for me to understand on a deeper level, not only what is going on in my ecosystem and this transfer. Carbon is a huge part of energy in our ecosystems. Carbon to carbon bonds. It's a triple bond, y'all. It's super strong. That's why things that eat trees, consume trees, and they have to eat so much of it because of how hard it is to break those bonds, but also they can be massive. Think of a panda bear. They eat cellulose, man. Cellulose is a carbon to carbon to carbon to carbon to carbon to carbon chain. It is strong. And that panda's huge, and it's huge for a reason, because those carbon bonds hold so much energy. And so when we begin to look at these things like the carbon cycle, the water cycle, we're starting to understand how energy is moved through ecosystems. And if we can understand how energy is moved, we can manipulate it. And if we can manipulate the movement of energy, we can store it and we can use it. We can use it for ourselves, and we can use it for those that we steward. And we can begin to maybe harness some of this really chaotic energy that is flying around in our ecosystems right now, because of how much disharmony there is. And so let's look at a basic way that a carbon cycle exists. This is not complicated and it is not complete. Okay, there are resources in your outline that you can dive in to understand more about the carbon cycle. So, David, you're going to start us off. I want you to go from atmospheric carbon down to diffusion to the ocean. What is that process that is happening right there? Can you see it? Do we need to bump to
Yeah,
the next?
I might need to a magnifying glass because I'm remember. No, I haven't
Okay.
set up my tablet, laptop, whatever it is that I got. So
That's
I don't have
okay.
the so
Okay, so for this exercise, we'll skip you since you can't see the diagram, okay? But you'll be able to hear it and the way that we all talk about it, okay? Okay, so Nala, what is the process when we're talking about atmospheric carbon down to diffusion of the oceans? What is that process that we're talking about right there?
Like, you want me to read what it says on there? So it shows from, I'm not sure where I should start. Well, if I start,
My question is how is this diffusion happening? Right? So it's atmospheric carbon is diffusing into our oceans, right? This is one of our major carbon sinks is our oceans. And how is that happening? What is this diffusion process? Just name one of the many.
respiration.
What is respiring? I think I said that right. What's You want to call a friend? We got a friend she can call.
Yes. Let's see.
Both Jasper and David said that you can call on them. Carol said you can call on her.
Oh, we can go back to David then, since then I know he was working on it at first.
Go, David.
all right. Kind of like, heard what you were saying. Well, carbon gets collected in the atmosphere.
Into the
Through-
ocean.
Yes,
The question
but
is how does it diffuse into the ocean?
rain. Number,
Yes.
I would say it's
One
the
is rain. Yes. What is another process, Jasper?
That was the one I was gonna say. I'm
Okay.
not sure of any others.
That's okay. Carol, what is another process? How does atmospheric carbon diffuse into the ocean? A huge carbon sink.
From the atmosphere into the ocean, of course, rain, anything precipitative wise. I'm also thinking, but it doesn't come from the atmosphere, but stuff that decomposes in the ocean has an effect on but this is not atmospheric, but that produces carbon in the waters.
Absolutely. Something else. Andy.
Well, does that include that what did you say? Not perspiration, respiration. Include, like dew and humidity and clouds and all of that? All of that included, like
I would
in
say
that same.
Yep, that's they consider that precipitation. So something that we're maybe missing right now is the massive amount of life in the ocean. So we have coral reefs, we have plankton, we have kelp, and that actually the respiration of those plants is a huge carbon sink. And through the diffusion of actually just carbon in the air through water actually is a huge amount because of those plants. Is that making sense? It's not just a significant amount of our oxygen that is produced comes from these life forms in the ocean, but also a significant amount of carbon that is from our atmosphere is being exchanged with them as well. Is that a hand, or is that like I'm thinking, Carol?
No, that's part and part thinking, because, then you think about not just the plant life, but the animal life, the marine life, because then and how they breathe underwater is through the water taking in oxygen. But I'm not sure about their respiration if then they emit CO2, because I'm not a marine biologist. So
It depends on the organism. Some do.
okay.
Yes. And it is actually, that is a great addition, because nothing is ever alone, right? When we're talking about an
Mhm.
ecosystem. So yes, it is also the incorporations of larger organisms that also respire through gills, right?
Mhm.
And other ways that are creating a pressure difference, which creates diffusion through the water. So it's the quantity of both oxygen and carbon monoxide and carbon dioxide in waters in the different layers, because they have different densities and in different habitats creating different quantities, and the quantity in the atmosphere that is creating a diffusion. Is this making, I'm trying not to get super complicated, but I'm also not trying to just elementary you all.
No, it's good. It's creating some good understanding. And so then when those larger organisms are pulling oxygen from the ocean, then it can potentially, right, create imbalance because of the increase in carbon, especially if we continue to pull water out. And
they themselves producing carbon monoxide or carbon dioxide into the ocean isn't what's creating the imbalance. What's creating the imbalance is when maybe there's one species that has a high amount or very, very depleted in a whole ecosystem, right? Because it's the balance between these species that's creating the pressure between the water and the air, which is pushing in the amount of diffusion of carbon from the atmosphere into the ocean. And so when there's something imbalanced in either systems, right? If we look over here, if there's too much combustion, not enough photosynthesis, there's too many life forms producing atmospheric carbon. The pressure of carbon it sits in a specific layer in our atmosphere because of its density, right? And the pressure within our ocean. So there's going to be a certain amount of diffusion between the two of them. And so when we offset and make these out of harmony is when it's the issue. Is that making sense? Yeah. Making sure I'm not losing y'all. Any questions about that specifically? Okay. So we talked about diffusion here. Now let's move over into this process, right? We have a lot of things that are producing carbon, right? The extraction of fossil fuels right here. And that in its process itself produces carbon because of what, Andy?
The process of us using the fossil fuels
Of
creates carbon.
extracting fossil fuels.
Extracting it, yeah.
Mhm.
Well, whatever tools we're using to do that, like the factories, drills, trucks, transportation.
What process are they using in this cycle?
Heat.
This combustion, right? They're burning it. They're burning the processed fossil fuel and combustion. And so they're adding to atmospheric carbon. So we could actually add an arrow of combustion just from this extraction process as well. Okay, and so then we have factories that are refining the fossil fuels, and in that process of refining fossil fuels, there is combustion and an increase in atmospheric carbon. Now we have biospheric carbon life fields, life forms, also with fields that are full of life. Through respiration and metabolism, right? Through breaking down carbon to carbon, we're releasing it and from long chains into short chains, and the atmospheric carbon is increasing. Now there are things that are taking in that atmospheric carbon, right? We have photosynthesis that occurs with things on the earth. We also have diffusion into our oceans. Now, if you think about in our current or our planet and how our biomes are designed, most of our land is covered by plants doing photosynthesis, right? And our oceans are mostly full of life that's pushing diffusion of atmospheric carbon into the oceans. If we think of coral, if we think of kelp beds, if we think of phytoplankton, right? These are massive quantities in our oceans that are actually doing a significant amount of photosynthesis. Some of them aren't doing photosynthesis, they're doing other types of processes that also push and pull this diffusion process. But if you look at how our planet is actually designed, is for a high level of photosynthesis to be occurring so that our atmospheric carbon is in check. All right, nitrogen cycle. Let's get into the dirty one. So there's a lot going on in this diagram. I'm only going to talk about some things because we could literally do our entire 3-hour class just talking about this nitrogen cycle. Let's break it down into really simple. We have, again, atmospheric nitrogen. It's most typically found in the form of gas. There are other forms of atmospheric nitrogen other than N2 that is found, and we are not talking about those forms in this cycle. We're specifically talking about N bonded to N in the form of gas. Okay, so you have nitrate, which is NO3, which is made through a decomposition process that's releasing N2 through denitrification into the atmosphere. That process is really important to us, this process, and the ammonium, NH4 plus, going into nitrite. I always say these things wrong, so you have to be patient with me as I slowly say them out loud. These two processes are really important because we utilize bacteria in specific plants known as legumes for these two processes. And it's actually through the decomposition, the denitrification of these bacteria that we're getting a release of this nitrogen for our plants that are requiring that gas, okay? And that's something important to know. So we have organic matter that is pushing ammonium. We also have urine that is pushing ammonium into our soils, and we can utilize that as a form of nitrogen for our soils. We also have biological fixation. We have factories, byproducts that are pushing ammonium into the system as well. We have a small quantity coming from atmospheric fixation, that's lightning that bonds two nitrogens together and with some particles from water, and then it actually rains down into the cycle. Any questions about the nitrogen cycle? Jasper.
Is that a little, I see the like representation of legumes, but is that like clover or sorrel that's also being represented there?
I believe it's clover.
Sweet, cool.
Any questions or even information share about the nitrogen cycle?
I just loved that video that you had included on this, because even just that little thing of like the nitrite having was it three? Well, no, that's now I don't even remember. Oh yeah, it was 2 types of vowels versus the nitrate, which has 3 types of vowels or something like that. Like I didn't need to know that, but it still was like, it was very helpful, like the whole process. Because I definitely struggle with knowing, like I know the nitrogen fixers in the garden, but like when then it comes to the animals and our waste and what's happening from above and all of that and how that feeds into this cycle, the video was very clarifying for me, for sure. So appreciate that. I'm sure I'll go back and watch that again. Actually, it was great.
Absolutely. And the major part of why PDCs talk about the nitrogen cycle is because a huge part of permaculture, and if we just go back to the principles, is the cycling of waste. There is no waste, right? And so when we know the carbon cycle, we know the nitrogen cycle, we know the water cycle, we know where this energy is coming from. We know where it's coming out of a system and it's coming into a system. And when we know those things, again, we can manipulate them. We can manipulate them to put that energy where we need it instead of leaching it out in places or creating an excess and then death, right? We know what that looks like because that's what's happening right now. But we can move these excess parts in our societies into more of a balance by knowing these cycles. I know it seems really simple, but it actually really is actually that simple. And these things are not considered. I'm going to tell you, these things are not considered when you talk to a civil engineer. These things are not considered. They don't know the nitrogen cycle. They know what they're taught in school, right? So we need to broaden and balance. This is just a reiteration of literally everything we just said. I got to make your faces disappear for a minute because this is so large and the people in this recording will never be able to see all this beautiful thing. So this is just, I can't see your faces. Again, want to just remind you, this is a reiteration of everything we just talked about. This energy flowing through the system is equivalent to heat energy that's lost from the system, right? Is also directly relational to the structure of an ecosystem and that whole ecosystem itself in a whole other way right here when we're talking about the producers, the decomposers, the primary conducers, and their energy exchange, also with the abiotic factors. Everything we just talked about is not separate from each other. Everything we just discussed is not something alone to think about. It's this broader picture right here. The energy movement, the nitrogen movement, the carbon movement, the energy movement, all is relational and all has a place within an ecosystem. And the way that it shows up in that ecosystem with its biomass, with that energy transfer, with that heat loss is the way that we manipulate it. Does that make sense?
It does. So when you're saying like all of this inclusiveness, I think of what's going on our land, having been grazed, just clear cut and then grazed for 30 years or whatever, and how there are pockets of life on it, but then a lot within those between those pockets of life is are stretches of wasteland, stretches of nothingness, or seemingly nothingness. One of the observations that I wrote down when I was thinking about being up there off and on all summer was that I never saw a bee or a hummingbird. And that is indicative of, for me, pockets of nothingness, right? So this is very clarifying for me. Like the biggest thought that I have here is like, okay, how can we restore life slowly, because we can't do it quickly, to those stretches of wasteland, if you will.
This redistribution of energy,
Yeah.
right? So
Yeah.
you got to like either the wasteland is receiving too much of something or too little.
Yeah.
And so it's either being leached somewhere
Yeah.
or it's being dumped too much in one area.
Yeah.
Any questions or information that is coming up that you want to share about what we're looking at right now? All right, so let's apply that to this diagram. This is a little activity. I would like everyone to unmute if they can. And we're gonna do, this is rapid fire popcorn, okay? So we're gonna be talking about the forest food web. We're gonna we're going to place these different animals. Not these different animals, my apologies. We're going to fill in. Sometimes my brain is hilarious. We're going to fill in these blank boxes with the appropriate name. What is missing in this ecosystem that we just learned about? Okay, so let's start here at the bottom. What is it pointing at? What is down here?
Composers.
Decomposers. What would be another something else that would be down here? Decomposers and
Producers.
producers. Yeah, another form of producers. Okay, so then what is up here higher in this food forest web?
Carnivores.
And then what's up here also that we already mentioned?
Top carnivores.
Is this a top carnivore?
Or is that just the tree?
So what is this?
It's a producer.
niche?
Yeah,
It's a
it's a
producer.
producer. Is this making sense now? I
Mhm.
can see that I need to give clear directions. Thank you for showing that to me. Okay, so what we just did is just identify the different, not only niches of an ecosystem, of this ecosystem, but also that flow of energy. And then we named those different those different parts. And then let's turn what we just saw into a permaculture design. Boom. Everything we just learned about. And let's peer through these lenses of what we just learned about at a backyard woodland community, okay? And what we're seeing are producers, we're seeing consumers, we're seeing decomposers. Look, we got this bird bath here, we got a moist meadow community, an alpine drier community right here. Look at this pond community and that ecotone around it right here, that bog community. We have compost bins for our decomposers, a birdhouse, inviting in those, it could be herbivore, it could also be an omnivore, understory trees and a canopy. Here's a forest, understory shrubs, bird feeder, woodland floor, nesting egg laying sites, shelter, food, and water. Now, what people would see would be a pond and some native beds with some trees in someone's backyard. And what we as permaculture designers see are all these little tiny things that all intricately fit into each other and create harmony and a balance of energy exchange. Any questions or information share that anybody wants to offer about this picture? And oops.
I have to laugh because hearing you talk about how I don't remember what sector of designers or whatever don't see the, you know, know about the whole process of the permaculture and the tying it all together and everything. And I thought it made me think like, okay, well, permaculture designers then are, and educators are the ecotones between, you know, the maybe the
Traditional
yeah.
landscape.
traditional landscape or the homeowner, but then also God, well, I'm totally, it's like obviously 8:30 at night because I have no idea. And you just said this word, but like urban planner, or it wasn't urban planner, but
Civil
yeah,
engineer.
civil engineer. Thank you. Yeah. That they aren't taught that. And it reminds me of medicine and how they're not taught anything about nutrition.
Mhm. It's very similar
Mhm.
and healing different parts
Mhm.
of that whole, right?
Mhm. Yeah.
All right, I'm gonna go to I believe this is yeah, we're almost there. And then we're gonna take a longer break, okay? So we're I'm starting to bridge some topics we're going to talk about later. We're going to revisit this a lot more in the soil units, okay? But what we're talking about here is a succession. I'm not really going to get into this soil succession. What is here and that I'm beginning to introduce this topic to you is that succession has a direct impact on the ecosystem. Where a ecosystem is in a succession will directly change its habitat, what species are present, what niches are there, what if there isn't even an ecotone. And so succession over geological time is really, really impactful. And if you know where an ecosystem is in a succession, it gives you the power to be able to keep it in that succession, move it in a lower succession, or move it into a higher succession. That's what we get when we begin to understand succession. We begin to understand how to move an ecosystem from a higher succession to a lower. Any questions or information shares about this succession?
Well, I'm struggling with the why would you move an ecosystem?
I may move an ecosystem for maybe grasses, shrubs, and shade intolerant trees to maybe grasses and perennials if I need more pasture, right?
Okay, okay, that's good. I'm good.
Yeah.
Yep, thank you.
All right, now let's look at this and through a permaculture lens. I'm just trying to move your faces. I'm sorry. Okay, so Mollison, this is a diagram from the Permaculture Designer's Manual, and this is an evolution in a design system. So Mollison took a very low succession. Let's just hop right back over super quick. He started with this pioneer succession right here, where it's just small annual plants and lichens, okay? And then he moved it through a permaculture design system into a full forest, right? And this is an edible forest. So not only is it a higher succession in an ecosystem, but it's also producing specific types of output for a specific function. Again, I'm just layering what we're going to be, this is what we're going to start getting into, is these more complicated subjects of how do we leverage succession as a designer. This is how it's done. This is what you're going to be learning. Any questions?